Here is an example. Town A and B are located 6 miles and 3 miles, respectively from a major expressway. The point on the expressway closest to the town A is 12 miles. So in this, if we are looking from here to this point here is at 12 mile. And two roads are to be built from A to the expressway and then B express the combination length of the new rods F as a function of X as shown in the figure. So first of all, let's try here and let's denote this rod from point A to the express way. Let's denote with the F1. So this is this distance from here to here is a function F1. And now let express with the function F2 the other distance, so that is from the expressway to the town, to the next town, to the B town. And so, because this is a distance here, from this point is 12 feet, 12 miles, I'm sorry. 12 miles is from the town A to town B. So that's what they mean, 12. And now what we have here, is we want to find those distances. But because we have here in the form of the right triangle, as we say, this distance horizontally, we don't know exactly what distance is here. This is a horizontal distance, and that's why we denoted the x. And because here is at 12 miles, the other distance from this point to B is at 12 minus x. So that's what we have, those distances. And now if we are looking to write them into as a hypotenuse here, F1. So F1 square is going to be equal with x squared plus 6 squared. X squared plus 6 squared. And now if we are solving this for f, and we are taking square root of both sides, and the positive f1 is going to have a two solution, plus minus square root of x squared plus 6 squared. But we are taking, because we are in the real world situation, we are taking just the positive value, which is equal to the x squared plus 36. Plus 36. And now f2 is the same, f2, but is written is equal with the x, 12 minus x we have here, 12 minus x. Everything here is in a square. And is a plus 3 squared. So plus on this side here, 3 squared. So the hypotenuse of the triangle here is equal with the 12 minus x squared plus 3 squared. And if you take in the square root in the same way like we did with the function 1, f2 is going to be equal with the square root with the positive, because it has a two negative and positive, but because we are working with a real situation example, so we can take just the positive root here, no plus minus, but just a plus, that's the positive one, which is at 12 minus x squared plus 9. So we can simplify this f2 a little further, which is going to be 144, which if we are simplifying everything is going to be x squared. Let me try to simplify everything. If we simplify everything here inside the parentheses, is 12 minus x squared is going to be equal with the x squared minus 24x minus 24x And the last one is going to be 12 squared is 144 plus 9 is plus 153. Plus 153. And now we have a combining function here. So we have a combination of f1 plus f2. If we want to write as a combining length of the rod, it's going to be f1 plus f2. And in this case, this combination is addition, adding the functions, and it's going to be equal to the x squared plus 36 and the other part is going to be the f2, which is equal with this very long equation, x squared minus 24x, x squared minus 24x plus 153. I'm trying to squeeze here 153, 153. So this is the combination, and expressed this we already expressed the length of this rod and the other rod as a function as a function of x, and we already did it. We finished this example.